Okay, how would you describe how would you describe the relationship between the x and y values on the scatter plot? As the x's get larger, okay, so as the x's get bigger, the y's get smaller. Because isn't it going down? Okay, so then it says, based on the data in scatter plot number 1, what would you expect the y value to be for 2020? The x-axis is in years. So this is so this is 2020. So this is 2015, and then we'd have 2020 over here. Right? Yeah. So about here, I would say lower than 50, higher than 35. Okay, which correlation coefficient corresponds to the best fit line that most closely models the data in 1? It looks pretty much like that looks like a line, okay? So, and it has a negative slope. Since it's a negative slope, it can't be this one. It almost looks like an exact line, so I'm going to say this right here. Okay, the table below shows Kyle's bowling scores. Each week he's participated in a bowling league. So down here we have the week, and over here we have the score. So we have week 1, 2, 3, 4, 5, 6, 7, 8. I'm going to do a little thing here, and I'm going to start at 120. Let's see, 20. I'm going to go up by what? Let's see, 24, 28, 32, 6. Yeah, I'm going to go up by 4. So 124, 1 by 4 is 128, 132, 136, 40, 144, and 148. Okay, so number 1 is 122, so it's going to be about here. Oh, 122 would be halfway. Okay, and then 131, so that's going to be about here. And week 3 is 130, right about here. And 133, about here. 5 is 145. Okay, and 6 is 139. Okay, so if I'm looking at this, does this data go up or down? It goes up, so it's definitely not this. Where might it hit the x-axis? It's going to hit somewhere around 120. So that means that this would have to be our line. It says estimate Kyle's score for week 9. Okay, so that just means we plug in 9. So y equals 3.7 times 9 plus 120.3. So where'd my calculator go? Oh, 3.7 times 9 plus 120.3. I got 153.6. Okay, how do you explain how you found this I plugged it into the equation for the line of best fit. Okay? Oh, and we're talking points, so you should probably round that to 140 or 154. Okay, so the next one says find the equation of the line if you use data points from week 1 and week 3. So week 1 is 122, and week 3 is 130. Okay, so if I do this, get my slope, and my slope is 130 minus 122 over 3 minus 1. So I'm going to get 8 over 2, so my slope is 4. Then I'm going to get an equation of the line, y minus 122 equals 4 times the minus 1. Y minus 122 equals 4x minus 4. Add 122. Y equals 4x plus 118. Okay. So, finish the statement about the data. As the number of weeks increases, as the number of weeks increase, the score also increases. The score increases. Okay. Describe the scatter plot, describe what it means for a scatter plot to present a negative correlation. Give an example of a situation that would create that type. The x increases and y decreases. We could do, let's see, x are the minutes leaving school. Y is distance from distance we're just going to do time. Just do time, minutes, and distance from home. What is the difference between correlation and causation? Correlation does the data all go in one direction? Causation does one part affect the other part? Okay, which residual plot below would indicate a linear? This would be linear. This would be nonlinear. Line of best fit defined as a line that connects all the data points, a line that might best estimate and be used for predicting values, A vertical line, no vertical lines. A line that has a slope greater than 1, not necessarily. Nope, it's going to be B. So make a scatter plot. Plotting a scatter plot relating the ages to the percent of people's budgets spent on entertainment. Age. Oh, I should make. Age. There we go. So we're starting at 30 and we're going up to 80. So, no, don't even do that. 10, 20, 30, 40, 50, 60, 70, 80. And then we're doing times percent on entertainment. So 1, 2, 3, 4, 5, 6. And then this is percent spent on entertainment. Okay, so 30 is 6.1. 40 is 6. 50 is 5.4. 61 is 5. 70 is 4.37 and 3.4. Okay. Which equation should be used? Okay, so it's got a negative correlation, so it's not this and it's not this. The y-intercept is not negative, so it has to be this. Okay. Ooh. Let's see. Then it says predict the percent for a 65-year-old. So you're just taking that equation, y equals negative 0.05, putting in 65 and finding that answer, and you should come up with 4.3%. Okay, is it reasonable to use an equation to estimate the entertainment spending on all ages? No. It is not reasonable. Especially in this day and age, because a lot more people are using it. As age increases, scores, or not scores, percent spent decreases. I was still on the last problem. Okay, this one. Use the table and scatter plot, which shows the number of hours different players practice basketball each week and the number of baskets each player scored during a game. Use the graph and the data to sketch the line of best fit. Okay. Okay, and then the slope is 0.726. That means for every say for, how do I want to say that? There we go. They made 0.726 baskets. There we go. In 1 hour. Identify the y-intercept 3.27. Oh, not in every hour. I want in hour per hour, I think sounds better. Meaning, without practicing, you can make 3.278 baskets. Okay, which of the following is a good estimate? Well, it's a positive. I'm going to go with this. Okay. So, we are going to, I'm going to rewrite this equation down here. Y equals 0.x plus 3.278. So what we're going to do is we're going to take the hours and we're going to plug it in. So if I plug in the hours, I would get 6.91. If I plugged in 10, I would get 10.54. If I plugged in 7, I would get 8.36. If I plugged in 0, obviously I would get the y-intercept. If I plugged in 12, I would get 11.99. If I plugged in 3, I would get 5.46. If I plugged in 9, I would get 9.81. And if I plugged in 6, I would get 7.63. So then the residual, I am going to take, in order to find the residual, you take the actual and you subtract the predicted. So I'm going to subtract them. So if I subtract those, I get negative 0.91, 0.46, negative 0.36, negative 1.28, 0.01. It's interesting how close that is. 1.54, negative 1.81, and 2.37. Okay. So 5 is going to be negative 0.91. About here. And 10 is going to be 4.6. Or sorry, 0.46. I was like, wait a second. And then 7 is going to be negative 3.36. So that's going to be here. And 0 is negative 1.28. So here. And 12 is going to be, oh, so close. So close. And 3 is going to be 1.54. Oh, 3, not 1. 3 is 1.54. 9 is negative 8.1. and 6 is 2.37. Oh, nope, that's way above that. What was it again? 6? 2.37 here. Okay. Is it a linear model? Okay, so yes. Okay, there's no pattern to it. It's scattered randomly. That makes it good. So is it number 11? Okay, number 11 says Mrs. Burhan's class took the Unit 2 quiz and the Unit 2 exam. The scatter plot of the data is shown below. The graph shows what type of correlation. If I look at this pretty picture, it looks like a positive correlation. And I'm going to say strong. Okay, so next. So if a student scored 60% on the quizzes are the X value. So I'm going to plug it in. Y equals 1.0363. And I'm going to plug in 60%. I think it's just plugging in 60. Yeah, just plug in 60, not the... Okay, and if I do that, I'm going to get 64.18%. Which of the following is true about the data? Someone scored 68% on the quiz, but got over 80% on the exam. 68, so 68 would be here, and they got over 80%. Yeah, I can see that. That would be good. The student who scored between 65 and 70, so 65 and 70, somewhere in here, the quiz earned strictly between 70 and 80. No, because you have this one up here. So no. Okay, so let me get rid of all of what I'm drawing on here so I don't mess up on the next one. A high score on the high quiz score, so those over here, definitely means you get a high score on the exam. Well, it depends what you think a high score is, because this person got an 80%, but then got lower than 80%. 85, but I'm going to question mark that one. Then the next one says a slope of 1.0363 means that in general did better on the exam. Oh, because it's positive? Yes. A y-intercept of 2 means that if you got 0%, yes. Sorry about that. Alexa, stop. The correlation coefficient is closer to 1. Oh yeah, because it's a positive. It's positive. I'm not sure about that number 3. That could be true. Okay, so this next one, number 12. Okay, which scatter plot best describes the following? A quadratic. Oh, I think that's 2. Linear, I'm going to say that's 1. No relationship, 3. Because look, line. Okay, scatter plot blank could be used about shoe size What does shoe size have to do with the ACT? Nothing. Could be the height increases, the weight tends to increase. As you get taller, you weigh more. I'm going to say that could be one. How over time iPad sales increased and then decreased. Increased, decreased. So I'm going to go with 2. Sophie drew a line of best fit with these 2 points. Write the equation of her line of best fit. Okay, so find the slope first. So I'm going to do 75 minus 3 over 11 minus 2. I'm going to get 72 over 9, which is 8. So y minus 3 equals 8 times x minus 2. Y minus 3 equals 8x minus 16. Add 3 to both sides. Y equals 8x minus 13. Okay, Laura drew a line of best fit through these 2 points. Write the, okay, same thing we just did above. 22 minus 7 over 43 minus 15. 15 over, let's see, that's an 8. That's 28. So it doesn't simplify. So y minus 7 equals 15 over 28. X minus 15. So y minus 7. Did I subtract right? I'm feeling like I didn't subtract right. So 22 minus 7, 15, 43 minus 15, 43 minus 15, 28. No, I did it right. Okay. Somebody has the wrong answer in the answer key. 22 minus 7. Yeah, that answer key is wrong. 15 over 28x minus 225 over 28. Add 7. So y equals 50. I think they meant to change one of those numbers. I don't care. I can do this. Okay, 28 times 7. So this is 196 over 28. So 225 minus 196. So this is going to be minus 29 over 28. Yeah, somebody messed that up. Use Desmos to complete the following problem. Okay, so you plug that in. You did not learn least squares, but if you want to know what it is, it's okay. The correlation coefficient, if you plugged it in, you should have gotten 0.98. So that means it's a strong positive correlation. Okay. So if you plug it in, y equals 11.73 times 410 plus 193.85. You will find that that answer will come out to 18.43. And then if a sandwich has 27 grams, wait a second. Oh, no. That's wrong. I apologize. I was going to say that came out really wrong. This should be 410 because this is calories and that's the Y value. And that should come out to the 18.43. And then this one, you plug in 27 for x. 3.85, and you should come out with 510.56. There you go.